We are starting our new journey in machine learning. I will be posting lectures and videos as I move along and have a clear understanding for you guys as well, that the topic we are covering is end to end covered. So, my first topic for this course is the machine learning process. What usually happens in the machine learning process? You will be practicing a lot of these machine learning processes as we move along, but in general, what is the outlook of it? So as you are seeing, this is the data pre-processing step, which contains three processes inside it: process of importing the data, cleaning the data, and splitting into training and test sets. This is called data pre-processing. Generally speaking, about data pre-processing, importing the data and cleaning takes up some time. You cannot just have a clean data right off the shelf. You have to run some processes to make out for some missing values, some uh, garbage values have to be cleaned up, some null values have to be taken care of. So all the database things that we have learned or we know from our SQL knowledge of the tables, those uh, um, features, I would say, those columns which can potentially skew your data, those have to be taken care of. We will be then uh, converting the whole data set that is given to us as a sample data set that is given to us into training set and test set. So that is essentially the data pre-processing step. Then we'll come to the real meat of it, the real brains of machine learning, which is called modeling. We will going to be building the model, training the model, and make predictions based on that model. So this is where we will be using some methodology to build our model. Once our model is there and is ready to intake the data, then we will train that model. Then after that we will make predictions. Whether that prediction is correct or incorrect, that depends upon the accuracy of the model, and that comes down to the next checklist: the evaluation of our model. Calculate the performance metrics, make the verdict about it. Is it that model that we build is actually really serving the purpose, or is this just the model that we built, it is not helping us in the situation? Usually it's a business situation, right? But it can be anything else as well. um, when we talk about building the models for finding out, uh, let's say, a Tesla car on the street, it is continuously learning and training itself, or it is being trained at Tesla facility of what kind of um, obstacles or hazards that it can see on the road. But on the other side, these model can explicitly be trained. I can imagine that they would have trained the actual model of that car on the road and also in the simulation lab, right? So that's where they built the model. Now actual performance of it comes out that once the model is ready, is that if that model is performing well, yes or no. Let's take a different example. Let's imagine that you go on Blue Book of cars, where you want to understand whatever the value of the car is. So a car is for sale, and you know that certain model and certain make and year model of that car will have certain value to it. It cannot exceed that particular value. So imagine you are given the task to predict the sales price of that car. The features that are given to you are only two features. I'm calling them features, but usually in the database language or database lingo we call them columns, but here they are called as features. So if you look at the features, their mileage and the birthday or the actual manufacturing date of that car or its age. Of course, that's not a lot of feature, but obviously in a real scenario where if you go on Kijiji or marketplace or some other places where we want to search for a car, we all have all sorts of different features that we can put the filter on to further narrow down and further squeeze upon what we need for the car. But that's us. If a model has to predict that, not us, in general, what are those features that we are looking at that a particular make and model and the year of the car should have certain value, so that we have to train that model. So right now, this imagine that we are given 20 cars. We are seeing these 20 cars along with their dollar values. um, so out of 20 cars, we will, let's say, split. I will not say let's say, it will be actually the same thing over and over again. We will be splitting 80%. When we will be splitting the data, the training set will be 80%, which is 16 records, and 4 will be for the testing our model. So the 16 records that we will choose will actually work for training the model, and then those 4 ones we can use it for actually testing the model, and we can actually provide extra tests so that it can predict us maybe the 21st car or 22nd car or 23rd car that we wanted to find out in that. As I mentioned, 20% will be for the test set. The model that we are going to be using in this scenario will be the linear regression model, but this is not the only model that we will be learning. We will be learning some other models as well. But let's start with the linear regression, which is the most simplistic form of the model. %80 will going to be the training and 20% will be going for the test. Once our model is trained based on this equation or this mathematical formula, which looks a little bit complicated at the moment for those who haven't learned linear regression for a long time, this y is the prediction value. Y cap means predicted value. And luckily for us is that we also know the actual dollar value of these cars. So we can see the difference, how far we are in predicting the value and what is the actual value or the certain price of that car. So as you can see, we will have the dollar amount predicted, and all these green ones is the actual values of y. After that, when we check the predicted value versus our actual value, we will be able to be in the situation to say that, oh yeah, our model is performing good, medium, or bad. If it is bad, then we will not be using that model. We have to do some other machine learning model to better give us the idea. Feature scaling. We are going to talk about feature scaling, and one thing I wanted to show you is that feature scaling will be not as easy, which I will be explaining, but in general, if you talk about feature scaling, you will be applying it on the columns. Let's see in an easier way what is feature scaling is. I will go down further slides and you will see that, but as I mentioning it here, that it is be applied to the columns. This is just a normal dummy data. This is not an actual data that we are currently working upon. I'm just going to highlight this yellow line just to show you guys what is the feature scaling. So there are two types of feature scalings available. One is the normalization, standardization, and the other one is standardization one. So what is the formula for the normalization? It's very simple. It's picking up each value and subtracting it, subtracting the minimum value in that set, and then dividing it by the maximum and minimum. In general, we will not be using this too much, the normalization. In the course, we will be using the standardization way of it, but it's easier for us to understand normalization in the normal example that I'm going to proceed in these slides. Standardization will be the ones that we will be using in the actual model that we will be training. So that's what I explained to you, is subtracting the minimum and then dividing it by the difference of maximum and minimum. On the other hand, so all the adjusted values will be adjusted in this way between 0 and 1. In standardization, we will be looking at, we will see the example of it very shortly, so don't worry about that. In the standardization, we will be subtracting it from the mean and dividing it by the standard deviation. So this is the formula for that, and for that we need to calculate the mean and standard deviation for the whole set. So this is a little bit longer process, and I'm not going to adopt that in this example, but we can be seeing that in the actual videos when we'll be going through that. So with the standardizations, all the values will be standardized to between -3 and +3. And this is just a general scenario that you will be seeing, that the whole data set values will be divided or spread across -3 and +3. So it's magic. It's kind of a magical value between -3 and +3. The annual income of the person and their age. So we are going to start our example. We are going to find the relationship first, that what is the relationship between the income of the person and their ages, and how closely people are in terms of in their career, in terms of their age and the value and the salary they are making based on their age. So we are going to have three people. 70,000 for this person, aging 45 years. 60,000 for this person, aging 44 years. 50,000 for third person, which is red, 40 years. So blue, purple, and red. So now we are going to ask this question, that which of the two people the purple person is closest to, whether it is closest to the blue person or whether it is closest to the red person. By looking at this example, you would totally ignore the age and the salary. You will consider the salary but not the age, right? In general, that's what our idea is. We are so blinded after seeing the big numbers that we totally ignore the smaller numbers, which is 45 years. So I would like you to think about that for a moment. What will be the purple person is closest to, whether it is closest to blue or whether it is closest to the red person. Okay, so once your thought process is done, you can pause the video and you can think about that, but I'll continue my lecture here. So this is more relevant for the clustering task, which is again one of the machine learning branch which we will be covering, but we'll come back to it once we hit that chapter. So for this kind of thing, for this kind of scenario, we apply feature scaling. In general, you will start by naively looking at, okay, the difference between the salaries is 60 and 70 is 10,000, and 60 and 52,000 is 8,000. So it looks like this person, purple person, is more closer to the red person. But hang on a minute, you haven't actually looked at this column or this feature at all. You totally ignore that. We cannot simply ignore that. What if this years will be in terms of minutes or seconds? Then you will be naively not looking at this column. You will be moving on to this one and say that looks like this person is closer to this or this person is closer to that. So we don't want these things to be happening in our actual real data set. We want real answers. So let's see how we'll tackle this problem. So we might end up in the erroneous conclusion, which we don't want. We make a wrong judgment that purple person is closer to the red person. But let's see how we can tackle this. So this is the feature scaling using the normalization feature that we just discussed a while ago. We will normalize this data accordingly. And what is the normalization? Whatever the value is 70,000 minus the minimum value, which is 50,000, divided by 70,000 maximum value minus the minimum value, which is 52,000 again. So same thing, you will have 1 for that. You will go with the second feature scaling, and then it will be becoming 0.44, and the third one will become 0. So take on your calculator, put in that formula, and you will have these values for this feature. Now let's move on to the next feature, which is our age. If we apply that same formula of normalization to our age column, we will have these values. So the purple person is the most is right in the middle after looking at the feature scaling, because if I look at 0.44, this person is 0.45 or 0.5 actually, if I round it up a little bit, but you might be tempted that it is more closer to 0, but it is getting right up there towards 0.5. But this is the actual deciding factor, which became here, saying that 0.8 is more closer to 1 and it is farther from 0, and that makes us help in the decision that purple person is more closer to the blue person. And that's it. So this is an illustrative example of feature scaling, but we will be doing the feature scaling using the standardization feature, keeping that in mind. But this is just an example that we cannot just simply judge by looking at the numbers and saying that this person or that person is closer to that, or to that person, or it is it is not as accurate. So that is my feature scaling and machine learning pre-processing data lecture for you guys. Thank you.